So to work out an inverse of a matrix, we have 3 steps to follow, right? 1, we're going to find the determinant of the matrix. 2, we're going to find the adjoint of the matrix. And then we are going to do a scalar multiplication at the end to complete our solution. Right, so what is a determinant? A determinant of a 2 by 2 matrix, remember this is the order of the matrix, which is generally the matrix that you would see, that they will ask you to find an inverse of a 2 by 2 matrix, is given that A is a matrix A, B, C, D, A with 2 straight lines is known as the determinant of A, right? So if you see that, they're talking about the determinant of A, and can be calculated as AD minus BC. So if you look at A, B, C, and D, ultimately what it is the diagonal subtracting each other. So A by D, first element by fourth element, subtract second element by third element. So that's where we got AD minus BC, right? And that's it here. The determinant of A is equal to AD minus BC. So it's straightforward. So let me get into it, right? Example, A is 3, 2, 1, 4. Find the determinant of A. Now the determinant of A is just what? AD minus BC. We know that AD is 3 by 4 minus BC is 2 by 1, which is just 12 minus 2, which is 10. Any questions there? So what we need to know as well is that if the determinant is not equal to 0, like this, it's a 10, so it's not equal to 0, it's a non-singular matrix. If the determinant is equal to 0, let's say work this out and your answer is equal to 0, it's a singular matrix, right? So once your determinant is equal to 0, it's a singular matrix. If it's not equal to 0, it's a non-singular matrix. So let's jump in to find the determinants of the following and determine if they are singular or non-singular. But let's do the adjoint first, because this is asking us about the adjoint. Right? So that was the determinant, number 1. Now, number 2 is the adjoint of a matrix. Now, the adjoint of a matrix is just changing the format of how the matrix is. So A is equal to A, B, C, D. A adjoint is actually equal to, you're switching the positions of A and D. So D is coming up at the top and A is going down at the bottom diagonally. And then it's going to be negative B, negative C. Now that negative doesn't mean that whatever the number is just going to be negative the number, or the number will always remain negative. That's not what it means. It means if the number is negative 2, then it will be negative, negative 2, which will ultimately give you positive 2. So you just have to negative whatever the number is there. And if it ends up as a negative, fine it. But if it ends up as a positive, you have to put it as positive, right? But as we get into those examples, you will see what I am talking about. Right, so A adjoint will be DA minus B minus C. So for example, 1, 2, 3, 4 will end up as 4, 1, negative 2, negative 3. Any questions here? So what we can do is take our time and write down the notes quickly, right?
I think use.
So we have some questions here. Find the determinants of the following. Determine, and determine if they are singular or non-singular, and write their adjoints. So first one, the determinant A is equal to AD minus BC, which is 21 minus 24, which is -3. Everybody good with that?
Yeah, miss.
Yes.
D now is equal to 4 by -1 minus -3 by -2, which is -4 minus 6. So that's -2. All right. No, -4 minus 6. So that's -10. Right? L, the determinant of L, -5 by -4 minus 2 by 10, which is 20 minus 20, which is 0. Yeah?
Miss Pretty is positive too.
Yeah,
So
Miss, I
D
never thought that negative.
-4 minus 6. Oh, +2. Okay. So -4 minus -6, which is +2. All right. All right, nice. So is A a singular matrix?
No.
No. Right? It's non-singular. Because the determinant is not equal to 0. What about D?
No.
Non-singular. What about L?
Yeah.
Singular. So who was answering there?
Alexis.
All right, nice. So singular, non-singular, non-singular, singular. Now let's do the adjoints. A adjoint is switching the places of the 3 and the 7. So 7, 3, and then negative in 4 and 6. -4, -6. Everybody get with A adjoint?
Yeah.
All right. D adjoint is switching the place of -1 and 4, and then -3. So this is what I was talking about here, Anastasia. Negative, but it's already a -3, so -3. Yeah, and then -2, which will give me what? -1, -3 is negative, by negative, so positive. So you'll end up +3, and then -2 and 4. Yeah. So not because we're negative in it means that we'll end up with a negative all the time. Yeah? Anastasia, do you understand that?
Yeah, sorry.
All right. And now L adjoint is -4, -5. I like to do the diagonals first so I don't mix up anything. So I just switch -4, -5, and then negatives, -2, -10. Yeah? And that's our adjoints. Yeah? Any questions here?
Yeah, Miss.
Are we good on singular matrix? Are we good on determinants? Are we good on adjoints?
Yes, miss.
No questions, right? So, to find the inverse, we combine the format above to form this. A inverse, a to the power of -1, which is just inverse, is equal to 1 over the determinant multiplied by the adjoint. So remember, I told you that we need 3 things: the determinant, the adjoint, and then to do our scalar multiplication. So now we're gonna see what I was talking about. So A inverse is 1 over A determinant of A by A adjoint. D inverse is 1 over the determinant of D by D adjoint. L inverse is 1 over the determinant by L adjoint. So we remember what the determinant of A was? -3, right? So it's just going to be 1 over -3. Yeah? By A adjoint, which was 7, -4, -6, 3. So remember, scalar multiplication is just taking each term and multiplying it by the number on the inside. So -1/3 by 7 is -7 over a third. -1/3 by 4 is just +4 over 3, because negative by negative is a positive. We don't need to simplify it. We can leave it in proper formats. -1/3 by -6, of course, you could put these things into your calculator, right? -1/3 by -6 is just +6 over 3, which is +2. -1/3 by 3 is just +3 over -3, which is just -1. Any questions here?
No, miss.
No. So let's do D inverse. The determinant of D is 2. So 1 over 2. D adjoint is -1, 3, -2, 4. When we multiply that using scalar multiplication, we'll get a half by -1, -1/2. A half by 3, 3 over 2. A half by -2, which is -1, and a half by 4, which is 2. And that's that. Now, L inverse is a little different because the determinant is 0. Remembers what happens when a number is being divided by 0. We always talk about this in functions when they ask for you to show something.
To substitute it.
Yeah, yes, but what happens when our denominator is equal to 0? What happens?
Fine.
What's that?
Is it undefined? You can't work it out.
Correct. It will be undefined, right, at this level. So that means if it's undefined, therefore we cannot work it out. So there is no inverse for a singular matrix. You could only find the inverse of a non-singular matrix. Yeah? Everybody with me and understand what I just said? So we can find the inverse for singular matrix, for a singular matrix, but we cannot find an inverse for a non-singular matrix because any number divided by 0 is undefined. Therefore, we cannot calculate it. Yeah.
Yeah.
Yeah, miss.
All right, take a 2. We good to move on? We need to write down anything here quickly. Guys, I'm not a mind reader. Are we good to move on?
Yeah.
All right. Thank you. So, all right, so what we're going to do is simultaneous equations using matrices, or solving a simultaneous equation using matrix method, right? It is not difficult because it consists of the inverse, right? So they'll give you a simultaneous equation and they'll tell you, use the matrix method to solve this simultaneous equation. What the first thing you need to do is put it into matrix form by separating the coefficients and the variables, right? So what you're gonna do is put the 4, the -5, pay attention that it's -5 and not just 5, 4, -5, 3, and 2 in matrix format, which is right here. Right next to it in a column matrix, you're gonna put X and Y in that particular format, or whatever the 2 letters are. If it's A and B, you put A and B. If it's L and M, you put L and M. If it's X and Z, you put X and Z. So 4, -5, 3, 2, X, Y equals to the solution in a column matrix, -6, 7. Right? That's straightforward. So, oh, sorry, excuse me. What we need to do next from there is understand that you could call it any other letters, but generally it's A for the name of this matrix, X for the name of this matrix, and B for the name of this matrix. So what you're going to do is you want to solve for X and Y. That's what a simultaneous equation is about, solving for X and Y. So you want to solve for X. And of course, you'll need to remove this. In order to remove this, you'll need to multiply A inverse on both sides. Because remember, the A inverse by the A, if we go back to the start of the notes, any matrix multiplied by its multiplicative identity will give you 1, 0, 0, 1. And 1, 0, 0, 1 multiplied by xy is xy. So 1 by x is x, add 0 by y is 0. So that's just x add 0, which is x. 0 by x is 0. Add 1 by y is y. So 0 add y is y. So the identity matrix by xy is giving us xy. So basically, that's what we'll end up with here. So A by x is equal to B. Because I want to remove A, I multiply by the inverse matrix. So I could say A inverse by A is I. So look at here, A inverse by A is I. Pay attention to this because sometimes they say, okay, what matrix can I multiply A by to get I, which is 1, 0, 0, 1. You could multiply A by its inverse to get I. Just to go back up to what we were doing. Okay, look, we have B inverse here, right? Just to see it. B inverse by B should give you the identity matrix, which is 1, 0, 0, 1, the multiplicative identity. What is B? B inverse is 1, 2, 2, 5, and B is 5, -2, -2, 1. When I multiply this, I should get 1, 0, 0, 1, because the inverse by B will give me the identity, multiplicative identity. 1 by 5 is 5. 2 by -2 is -4. So 5 add -4 is 1. 1 by -2 is -2. 2 by 1 is 2. -2 add 2 is 0. So we already seen it coming along. 2 by 5 is 10. Add 5 by -2 is -10. So 10 add -10 is 0. And 2 by -2 is -4. And 5 by 1 is 5. So -4 add 5 is 1. So we see it here that B inverse by B will give me the multiplicative identity, which is 1, 0, 0, 1. And if I have the multiplicative identity 1, 0, 0, 1, multiplying by xy, that will just give me back. Remember, it was also said that any matrix I by any matrix will give you back the matrix itself. So I is 1, 0, 0, 1 by a matrix xy should give me back the matrix xy. 1 by x is x. Add 0 by y is 0. So x add 0 is x. And 0 by x is 0. Add 1 by y is y. So 0 add y is y. So we see that. We can even do it with a 2 by 2 matrix. A, B, C, D. We will get back A, B, C, D because any matrix multiply by the identity will give you back the matrix itself. So 1 by A is A. A at 0 is A. 1 by B is B. B at 0 is B. 0 by A is 0. Add 1 by C is C. And 0 by B is 0. Add 1 by D is D. So we see that, right? So pay attention to this because you need to remember this. You need to remember that B inverse by B, well, any inverse matrix by its matrix will give me the multiplicative identity, will give me 1, 0, 0, 1 when I multiply it out. Any matrix, any identity matrix multiplying by a matrix will give you back the matrix itself. So this is what we need to understand for matrix multiplication, which is here. So remember, we want, let me remove all of this. It's A, X, B. We want to work out for X, so we multiply A inverse by A is equal to, of course, you have to multiply it on both sides, A inverse by B. We know that this goes to what? A inverse by A gives me what?
I.
I, correct? The identity, which is, and the identity by a matrix will give me what? I by X will give me what?
X.
X, right? Which is A inverse by B. Nice. So basically, this is all you need to remember. You don't need to put in all of that before, just that it's so you can understand why you have this line. So all you need to do is from here, go straight to saying, well, X is equal to A inverse B. That's basically all you know is that you're sending this across and it's going to be an inverse, basically, right? So A inverse A, and then I, X, and then X, A inverse B. Right, so A inverse by A is I. I by X is x because 1, 0, 0, 1 by xy is equal to xy, right? So let's go and work this out. We're working out the inverse of A to multiply it by B. So first step is A inverse is 1 over the determinant of A by A adjoint. The determinant of A is 4 by 2 minus 5 by 3, so 8 minus 15, which is 23, right? Now, that will be 1 over 23 by A adjoint, and A adjoint, remember A is 4, negative 5, so it's going to be 2, 4, negative 5, which is positive 5, and negative 3. And then we're going to do the scalar multiplication, which will give us 2 over 23. Two over 23, 5 over 23, negative 3 over 23, and 4 over 23. And that's the A inverse right there. So now we need to come back and we need to work out A inverse by B. So let's put A inverse 2 over 23, 5 over 23, negative 3 over 23, 4 over 23 by B. B was what? 6, negative 6, 7. So what we're going to do is multiply that out. Grab your calculators and start working with me. This is not something you want to try to work out. So you know you're going to do open brackets 2 fraction sine 23 multiply by negative 6, close brackets, add open brackets 5 fraction sine 23 multiply by 7, close brackets, equals. What will be the answer for that? Everybody remember doing row by column, right? So this by this, add this by this. What's the answer? Not supposed to take that long. Nobody has an answer for me? One, thank you. And then when we do the second one, row by same column, because it's only one column. What would we get?
So
2. Nice. And that's our answer for x, y. Therefore, x is equal to 1 and y is equal to 2. And we just solved a simultaneous equation using matrix method. Yeah? So it's not going to change. It's going to be the same steps. So what you're going to do is, of course, put it in matrix form. 4, negative 5, 3, 2 by xy equals negative 6, 7. Label it AXB. Then you'll just end up with x is equal to A inverse B. go on the side, work out the inverse if they didn't work out the inverse before. Because usually when they give you a question like this, higher up, they ask for you to work out the inverse of this matrix. So more than likely, you would have already worked this out. Right, so you know it's just for you to put the matrix in here, multiplied by the answer, B. Take your time and do your row by column, and then get your answer. And then you'll end up with x is equal to, put in your final line, x is equal to x is equal to 1 and 2, and y is equal to 2, right? Any questions there?
No, miss.
All right, nice. Lastly, we're just gonna run into equal matrices really quick, which is, I think we started it, but let me just give you another thing. Two matrices can be equal if they belong. No, we did this. We did this last class.
Yeah.
All right, nice. So we can stop here. So it's just for you to practice some inverse matrices and practice some matrix method to solve simultaneous equations. I am not going to give you any particular questions to work on because at this point in time, we already knew that we could pull up a past paper and get the same questions that we need to practice it, right? So that will be all for this particular session.